In this lecture, we're going to compare the feature of inlining variables and functions we just learned about in the last lecture to functions and variables that have internal linkage, like we have seen in a previous lecture. There are a few things you need to remember about these two features. Inlining will optimize all the definitions and make them as one. We have seen that the age variable we were manipulating in the last lecture was exactly the same thing in memory, even if we would have definitions that are confined to each single translation unit. But marking your function or variable as static or wrapping it in an unnamed namespace or an anonymous namespace won't do such optimizations. So if you look at this, you're going to see that using inlining is really going to be better than marking your functions or variables as static. Let's look at this in a little more detail. Here is a simple example describing what we just looked at in the last lecture. This is what we just did. We marked our age and function as inline, and this would cause for the compiler to unify all these definitions into one. We would still have them confined to each translation unit, so this here will be confined to our translation unit, and what we have in the other utility 2 translation unit would be confined to that translation unit. But we would still be manipulating the same data or the same things in memory from our application, and this is really important. The compiler is going to unify all these definitions into one because these things are marked as inline. But suppose you don't use inlining and you just want to use the features to mark things for internal linkage. For example, if you go down here, you see we have wrapped our data into a namespace, and we have a distance variable here, and we have some distance function which is going to print the distance. But this is not inline. This is just marked to have internal linkage, and the compiler is not going to do the optimizations to make these guys one thing. So if we have the same code here in different translation units, these are going to be two separate pieces of data. So the distance here in utility 1 is going to be different from another distance, for example, we might have in some other utility 2 CPP file, and this is the difference you need to be aware of. So if we had this same code set up, for example, and we try to call print age and print 2, and we have a setup that uses static or unnamed namespaces, if we print age 1 and age 2, we're going to see that they are working on the same piece of data in memory, but for the distance, because we are using the features to mark things for internal linkage, we're going to see that the distance variable in utility 1 is going to be different from the variable in utility 2, and we're going to see this in a minute when we hit Visual Studio Code, but I just want you to be aware of these differences. Inlining is going to optimize all the definitions into one, but marking your things for internal linkage either by using the static keyword or wrapping your thing in an anonymous namespace is not going to do such optimizations. Now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, so here we are in our working folder. The current project is inline versus static. We're going to grab our template files pretty quick and we're going to put them in place. And we're going to open this little guy in Visual Studio Code by dragging and dropping here. We're going to clean up the main CPP file, what we usually do, and we're going to set up two files. We're going to set up utility 1 and utility 2 pretty fast. We're going to do utility1.cpp and we're going to do utility 2. We're going to head over to utility 1 and put in the code we want to play with. I don't really want to type all this because it is really self-explanatory. We have done this a lot of times. So we have our variable age, which is inline. We have our some age function, which is also inline. The function is going to be printing the age variable we have on top here, which is also inline. And then we have a function with external linkage because it is by default going to have external linkage. And it's going to be usable from the main CPP file. That's why we are using this setup here. But this is going to be using the inline function here. If we go down, we're going to see that we have another function wrapped into an unnamed namespace. The function is going to be printing a distance variable which is not inline, but we're going to be printing this distance variable and seeing what we have inside. So this is going to give us a setup to be able to compare inlining to either using static things. For example, here you see the variable is static and the function is static, or using namespaces like we do here. And we're going to be printing the distance. We're going to see that the distance is going to be using a different variable. And if we print the age, we're going to see that it is going to be using the same variable because we have optimizations for inlining here. Okay, so we're going to head over to utility 2 and put in our code. It is exactly the same code, but it is marked that it is using data from utility 2 to be able to see things easily from the console when we get to use these things. Again, if you don't want to type these things, you can use the code that you can find in the resource section of this lecture. You can find a link and download all these things and use them as I am using them here. So now we're going to head over to the main CPP file and we're going to grab the definitions for print age and print distance. So we're going to go there and say print age 1 and print age 2. Let's grab this. We can copy and paste this in our main function and put in our declarations. And we can go down and do the same for print age 2. I think we can do this. Let's go there and make sure the name is the same. Yes, it is. We can also do the print distance function. We can grab this and put its definition in our main CPP file. We're going to make sure this is valid and we're going to put this in front and mark this as print distance 1. Now we're going to head over in the main function and call these guys. We're going to say print age 1 and we're going to call the function and we're going to say print age 2. That's going to be 2 here. We're going to put a separator and we're going to go down and say print distance. And we're going to grab the first function and we're going to say print distance. This is going to be the second function here. And we're going to try and run this code and see the differences we get from the print age functions here and the print distance functions here. The first thing we want to see is that this is going to work. We're going to try and see if this is going to work successfully. And it looks like we have a problem here. We have this guy with an opening curly brace. Let's fix this a little bit and see that this makes the problem go away. Okay, the world is good. Now we can run our program here. We're going to bring up a terminal to do that. We're going to clear and run rooster. We're going to see that from utility 1, the age is 12 and the memory address ends in 100 and the data is still the same. But from utility 1, if we do data for the distance, we're going to see that the data is the same, but the memory addresses are different. And what this says is that inlining is going to optimize the data to be the same in memory. But if you mark things for internal linkage like we are doing here in this namespace, this is not going to unify these two pieces of data we have in utility 1 and utility 2. What we have in utility 1 is going to be a separate piece of data, and what we have in utility 2 is going to be a separate piece of data, and we can see that in our output here. The data we have in utility 1 has a different memory address, and the data we have in utility 2 has a different memory address, and I hope this is really super clear. This is really all I wanted you to see in this lecture, understanding the difference between inlining and marking things for internal linkage, either through the static keyword or by wrapping things in anonymous namespace here. So to really see that it is the same here, we're going to comment out the namespace that we have. We can do this, and we're going to uncomment the things using the static keyword here. And we're going to head over in the utility 2 file and do the same. We're going to comment out the namespace, and we are going to uncomment things with the static keyword here. And we're going to build again with GCC. We're going to see that we're going to get exactly the same behavior. The build is good, so we can clear and run rooster. We're going to see that the data in utility 1 for the age data, the data is the same and the memory addresses are going to be the same. But for the distance variable, The data is going to be the same, but the addresses in memory are going to be different. And this is exactly what I want you to see here. This is really all I wanted you to see in this lecture, understanding the difference between inlining and using the static keyword here, or marking things for internal linkage either through the static keyword and the anonymous namespace here. One is going to optimize all these definitions into one in memory. The other is not going to optimize these things, and you're going to have separate pieces of data. That's why you should really prefer inlining, because it's going to save memory. You won't be wasting memory every time you use this definition in some translation unit in your program, and this is really cool. We are going to stop here in this lecture, and I hope you really found it useful. In the next one, we're going to learn about forward declarations. Go ahead and finish up here and meet me there.